Hello everyone. So now I'm going to solve numerical on this topic gravitation, which is from Irodov book. Okay. So let me start solving the numerical. So in the numerical, it's given that a planet, okay, of mass m. So as I told you in initial numericals that in Irodov there is a mistake that if it is told that planet of mass m, so it's not actually the planet of mass m. It's given the mass of the sun, but it's kind of printing mistake or whatever you can think. But actually this is the mass of the sun. Okay. So then the question, it means that the planet of mass, particular mass, say small m or whatever, moves around the sun of capital mass m, okay, along an ellipse, so that its minimum distance from the sun is equals to r and the maximum distance is equals to capital R. So making use of Kepler laws, we need to find its period of revolution around the sun. Okay, so making use of Kepler laws, we need to find the period of revolution around the sun. So let me solve it. Okay, so here it's given, suppose this is a planet. Okay, as you can see on your screen that it's a planet, and this is a sun which is easily visible. So given that the minimum distance, so planet will be having the minimum distance when this planet, suppose it is rotating clockwise. So when the planet will reach, when planet will reach tracing its elliptical path here, somewhat here. So when the planet is somewhat here, its distance from the sun will be the minimum, which is given as small r. Okay, and when the planet is here, its distance is maximum, which is given as capital R. Okay, so this distance is small r, and let me do like this. So this distance is small r, and this distance is capital R. And it is said that by using the Kepler laws, we need to find the period of revolution around the sun. Okay, so let us solve it. We know that the time period of revolution of a planet in an elliptical path around the sun is given by this t square is equals to under root, no, it's square. So I need to remove the square. Yeah. So it is basically equals to t is equals to under root a by gm 2 pi a. So this is the formula which you need to remember. I can just derive this formula, but for here, for this numerical, just remember this. If you want me to derive this this formula, just comment me in the comment box. Okay. So its time period is equals to 2 pi a under root a by gm. So this, let me mark it as first equation. Now squaring both the sides, it will be equals to 4 pi square a square, and this will be a by gm. Okay, so the time period will come out to be, square will come out to be 4 pi square a cube upon gm. Okay, and here a is basically, here small is basically semi major axis. Here small a is basically semi major axis. Now if you will see the figure, this semi major axis, suppose this is an ellipse. So let me make a semi major axis, show you that which axis will be the semi major axis. So basically this will be the semi major axis. This axis, this distance, okay, sorry, I mean this distance will be basically x, will be the semi major axis. Suppose, let me denote it with a, it will be more convenient. So this will be semi major axis. Now this, in this, according to the figure, this will be equals to, this will be equal to maximum distance plus small distance by 2. That is, the mean of the maximum and the small distance will be equals to semi major axis according to this figure, when the planet is orbiting around an elliptical path, in an elliptical path around the sun. Okay, so just we need to substitute this equation here above, and the answer will come out to be t square is equals to, t square is equals to 4 pi square and r plus small r whole cube upon 8, and this is gm. Okay, so this is the answer, and let me take the under root, then it will be equals to 2 pi r r. Okay, and this is r plus r upon this will be equals to 2 root 2, and this will cancel out. So the answer will come out to be, that is the time period of revolution of a planet around the sun in an elliptical path. In an elliptical path is equals to r plus r upon 2 gm. So this is basically the required answer. Okay, this is basically the required answer. So now I will solve the next numerical, which is 1.203, in the next video. Okay, till then, bye.